Welcome to my channel Learn It Well. Today from the Learning ShortKit, I will be taking up the page replacement algorithm from operating system. In an operating system, whenever a page is referred and not present in the memory, a page fault occurs and the OS replaces one of the existing pages with the newly needed page. The page replacement algorithm is a process of reading data from and writing data into the secondary memory. Whenever a process refers to a page that is not present in the memory, a page fault occurs. The page replacement algorithm is an important algorithm of the virtual memory management, and it intends to reduce the number of page faults. There are three page replacement algorithms that are employed with the virtual memory management concept of operating system. The first being the FIFO page replacement algorithm, that is the first in first out. It replaces the pages that has been in memory for the longest of time. LRU page replacement algorithm, that means the least recently used algorithm, replaces the page that has been least recently used. The optimal page replacement algorithm is replacing the page that will not be used for the longest of time. All the algorithms focuses on decreasing or minimizing the number of the page faults occurring. What is a page fault? When a computer hardware raises an interrupt or an exception when a running program accesses a memory page that is not currently mapped into the virtual address space of the program, a page fault is said to occur. When the page is replaced, a page fault occurs. The first in first out is the simplest method of page replacement. In FIFO, a track of pages is kept in the order brought into the memory, and the page that has been in memory for the longest of time is replaced first. The Belady's anomaly is a phenomenon experienced with FIFO, that is, a scenario wherein, when increasing the number of page frames results in an increase in the number of page faults for a given memory access pattern. For a reference string, find the number of page faults with the page replacement algorithms, that is FIFO, LRU, and optimal. So here we would be seeing that how many page faults are occurring for each type of algorithm. The reference string is given as follows. Now let's formulate the FIFO page replacement algorithm. We have been given a reference string and the number of frames are given as 3. That means 3 pages can be accommodated in the memory at a single time. So let's see how it is done. For a FIFO, when there is a demand of the page by a CPU, the page is brought into the memory. If the frame is free, the page can be well accommodated. But if there is no frame free, we would be replacing the page that is the oldest in the memory. So we'll see how it is done. So starting from 4, we would be seeing whether 4 is there in my memory or not. So here we say that all my frames are blank, so I would be taking the page that is demanded by the CPU into my first frame. So I have made the first page enter into the first, that is frame 1. Moving on to the second element, that is 7. So 7 has to be introduced into the memory. It is demanded by CPU. So again I can accommodate 3 pages at a time. So 7 can also be introduced without any replacement. Coming on to the next page, that is 6. So we'll be giving it a frame, that is frame 3. Now till here we have all the pages accommodated into the frame. Now any new page that comes into the memory has to be checked whether it is present in the frame or not, and if it is not present, we need to replace the same. So let's see for the next element. So we have traversed till here, so we are at this point, that is 1. So for 1, we'll see whether 1 is there in the memory or not. So we see that 1 is not there, so I need to swap in the page into the frame. I need to swap out one of the page from the frame. So we'll see that which page was the one that was brought into my memory first. So it is clearly seen that 4 was the page that was brought in the memory first. So we'll first mark the page that has to be replaced, and then we'll replace the frame. So we have traversed till here. Now let's come to 7. So first we'll check whether 7 is present in my memory or not. So we see that 7 is already present. So we make no replacement and it remains the same. Now come to 6. Now we need to check whether 6 is there in my frame or not. So here we check. So we see that it is present in the memory. So no replacement is made. Come to the next, that is 1. So 1 we'll check whether it is present in the memory or not. It is present, so we will be making no replacement. Next, coming to the page 2. Now 2 is demanded by the CPU and we see that there is no page 2 in the frame, so I need to bring in 2. So how to replace is that we'll see that we are keeping a track of the page that was last replaced. So we replaced 4 in the last time. So the page that was brought after 4 will be replaced. The page that was brought in after 4 will be replaced next. So 7 will be the page that will be replaced. So we would be marking it since we are going to replace this. So 1, 2 and 6. Coming to the next element, next page, that is 7. So we'll first check whether 7 is present in my memory or not. 7 is not present, so I need to replace the page from the memory and bring in 7. So how to know that? So after 7, what is the next element that was brought is 6. So we'll be swapping out 6 to swap in 7. So the next element is 1, 2 and 7. The next element is 2. So we see that 2 is already present in the memory, so no replacement is made. So we have the so we will not be making any replacement. So we have traversed the entire string. So there is one thing that we need to be careful of, that how many page faults and how many page hit we are making. So page fault is the replacement that we make, and page hit is the scenario where we make no replacement. So we need to categorize it into a page fault or a page hit. The page fault is also known as a page miss. So let's see which is the page fault and which is the page hit. So here I have definitely made a replacement, that is I have brought in the page. So this is a page fault or a page miss. So I will be determining the page miss by an asterisk. So 7 was brought into the memory, so this is again a page hit. 6 was brought into the memory, this was again a page hit. 4 was replaced, so there was a replacement done, so it is again a miss. But then if you can see here that no replacement was made here, here and here, so we say that this is a hit, that is a page hit wherein no replacement was made. Now here you can see that we have made a replacement, so this is a hit. We have again made a replacement, so this is a miss, and this is also this is a page hit. So count the number of page faults that we have. So we'll count that 1, 2, 3, 4, 5 and 6. So the number of page faults is 6. Taking up the next type of page replacement algorithm, the least recently used algorithm. The concept of LRU says that we would be replacing the page that is least recently used. So we'll take an example to understand this concept. So in the FIFO, we replace that page that was brought into the memory first, and here we would be replacing the page that is least recently used. So let's start traversing the string and understand. The same string has been taken as we took for the FIFO. We'll start with 4. The process remains the same, that we need to push the page into the frames available. So I have 3 frames, F1, F2 and F3. So here I'll say 4 is brought into the memory. The next is 7. So we bring 7 into the memory. The next is 6 that we would be bringing in next. With the page replacement algorithm, we say that the number of pages that can be accommodated is directly proportional to the frames that are available. So here there are 3 pages that can be accommodated at the same time. The next is 1. So from here, let's see how we make a transition. We would be dividing the string into the left hand side and the right hand side. For the LRU, we would be considering the strings that are on my left hand side. We would be seeing that which page was least recently used, that was immediately used in comparison to each other. So let's talk about the elements that are there in my frame. So first we'll check whether 1 is there in the frame or not. So 1 is not there in the memory, so I need to bring in 1. So 1 to replace 1, let's check which frame to target on. 6 out of 4, 7 and 6, 6 was recently used, 7 was recently used, and out of these 3, 4 was the one that was least recently used. So we would be swapping out 4 and we would be swapping in 1. So we would be making the replacement here like this. Now let's come to the next, that is 7. So again with this 7, I need to move to the left hand side, but before that I need to check whether 7 is there in my memory or not. 7 is there, so I will not be making any replacement, so the frames remains the same. The next is your 6. So 6 is already there in my memory, so no replacement is made. 1 is already there in my memory, so no replacement is made. Let's come to the element 2 here. So first we'll check whether 2 is present in my memory or not. 2 is not present in my memory, so I need to make a page replacement. Which page to replace? So I'll be again dividing the string into 2 parts, the left hand side and the right hand side. On the left hand side, I need to check out of 1, 7 and 6 which one of the page is least recently used. So 1 is recently used, 6 is recently used, and 7 out of 3 is the least recently used. So we would be replacing the page 7. So 1, 2 and 6. Let's come to the next element 7. Again we'll check whether 7 is present in the memory or not. 7 is not present, so we would be going for replacement. First we'll check which of the elements are which of the pages have been used recently. So out of 1, 2 and 6, 2 has been used, 1 has been used, so the next is your 6. So 6 is the page that we need to replace. So 6 will be made with replacement 1, 2 and 7. Let's go to the last page, that is 2. Now we'll check whether 2 is present in my memory or not. We see that 2 is present, so we would not be making any kind of replacement. Now we need to just mark with the page hit and page fault, page hit or miss. So here it is a miss, here it is a miss, here it is a miss, and here also it is a miss. But here we say that for this and this we did not make any replacement, so we call this as a hit. Coming to this, again there was a replacement made, that was with 7, so here it is a miss. 1 2 7, again the replacement was made, and here no replacement was made, so it is a hit. So again, if we count the number of page fault, we'll see that 1 2 3 4 5 1 2 3 4 5 and 6. So the page fault for the same string is 6. The third type of the page replacement algorithm is the optimal page replacement algorithm. In this algorithm, the replacement of pages that will not be used for the longest of time in future is considered. So let's understand this with the help of an example. The same reference string has been considered as we had taken in the previous two algorithms. The number of frames are 3. So we say that we have 3 frames that can accommodate 3 pages at a time. Starting with 4, we push in the page 4 as demanded by the CPU. The next is 7, so we would be pushing in 7. The next is 6, so we would be bringing in 6. After we have brought in the 3 pages, we need to go for the 4th element and see whether it is present in my memory or not. Taking the next element, that is 1. So first we'll check whether my element is present in the memory or not. So here we see that 1 is not present. So how to replace, which page to replace will depend on which page is not going to be used in the future for the longest of time. So if you can recall that in the previous algorithm, that is the LRU, we divided the string into 2 and we determined what is there on the left hand side. But for the optimal, we would be seeing the future oriented aspect. So we would be seeing that which one of the page out of the existing page is not used by the CPU, is not demanded by the CPU for the longest of time. So let's see. So we have to replace 1. So let's see what all elements we have on the right hand side. So we have 3 elements, that is 4, 7 and 6. So we see that 7 is already there, 6 is already there, so we cannot see 4 after the in the string. So we say that 4 is not being demanded for a very long time. So here what we do is we replace 4 and we put in 1, 7 and 6. Now let's come to the next element, that is 7. We'll check whether 7 is present in the frame or not. So we see that 7 is present, so no replacement is made here. Coming to 6, again we see that there is no replacement. 1 is also present in the memory, so we won't be doing any kind of replacement. Coming to the page 2, so 2 is not there in the memory, so we need to swap in 2. So we'll see that which one of the pages do not occur for the longest of time or is not demanded. So 7 is there, but if you can see that 1 and 6 is not demanded by CPU at all, so you can replace any of the 2 pages with 2. So let's say I am doing for 1, so 2, 7 and 6. So you can either replace 1 or 6. Why? Because there is no page that is 2 or 6 being 1 or 6 being used or demanded by the CPU for the longest of time. Then let's come to 7. So we see that 7 is already present, so no replacement is made. Then we come to 2. So again we see that there is no replacement that is being made, so we do not have any any page after this 2 page. Now we need to consider the miss and the hit. So this is a miss, this is a miss, this is a miss, and this is a miss. Here we say that there are no replacement 3 times, so we say that it is a hit. And here also, so there is one replacement that is made here, that is 1 is being replaced, so we have a miss here, and the rest of the 2 are the hits. So with LRU we see that the number of page fault is obtained as 0.5, that is 1 2 3 4 5. So we have received the value as 5. That is all from the Learning ShortKit of page replacement algorithm from operating system. Thank you for keeping up with my channel Learn It Well. If you like my content, do not forget to like, share and subscribe. Hit the bell icon for any notifications. Thank you.